All right, hi everyone. Welcome to the first CS50 super section. This will be the only week of super sections. After this, you'll be going to regular section with your assigned TF. But this week, we're doing it in a little bit of a different format. Although the actual format, how it's going to go for the next hour and a half or so, is going to be pretty similar to what you'll be seeing for the rest of the semester. So what we're going to do is start by going over the section part of your problem set. So if you've read over the P-set, which hopefully you have, you'll see that there's a part called a section of questions. And these are meant to be gone over in your section. So you have an advantage by being here, and that you get to kind of go over these more conceptual-based questions. And after we do that, we're going to go over the last two section questions, which are more dive into coding type questions. So we're actually going to have you guys take a few minutes for each question, try to solve them on your own, and then we're going to come together using the new CS50 Spaces tool and go over the answers so you all have the correct code to review. So a couple of announcements. Don't forget that there's office hours every night this week in Annenberg from 8 to 11. So do take advantage of those. And also, don't start the P-set too late into the week. Start tonight or tomorrow night at the latest. You will regret it if you wait too long to start and run into issues. So take our advice and definitely start early. This will be a good way to get started with these section questions. So I'm Lexi, by the way. I'm a TF. And this is Dan. He's also a TF.
Hey, guys.
And he's going to get started with the questions.
All right. So I'm going to just introduce a couple little compiler issues that we're going to talk about and just go through some sort of conceptual ideas that we need to actually run code, either in an appliance or with our sort of fake appliances run CS50 in spaces. So let's just see if anyone in the audience has any idea about what we're talking about. So what is a library in the context of code? Anyone have any idea? OK. Sweet.
Like a stock of functions that someone else already programmed that we can build off of?
Exactly. So a library is a stock of functions that somebody else has already programmed that we don't have to re-implement ourselves. So we have things like the standard IO library, the CS50.h library, that are things that the world, the internet, the staff have made that makes our lives easier as coders. So how do you print things to a screen? I have no idea. Printf does it for me. It's something somebody else has already made that is awesome and works quite well. OK, so to use libraries, on the other hand, however, you have to actually do some extra things with your code. So you have to use things like this hashtag include CS50.h. What does that do? What role does that play when you have it in a program?
It lets you make use of any functions that are within that library by simply by using the definitions that have already been given.
OK. It lets you pull library functions into your code, but it does it in a way that isn't exactly the same as like LCS50, which we'll get to in a minute. It just lets the compiler know that, hey, there are these functions that are going to come up in your code. Be aware that if they aren't fully described in the code that's in front of you, there's some library function that is going to take care of it. So in the case of Printf, which we'll go over a couple times today, it is the standard IO library. So while I don't define printf anywhere in my code ever, standard IO takes care of it for me. And I'll do hashtag include standard IO.h, or I guess, yeah. And it will pull in these functions that I haven't ever defined. So what is the difference then between this hashtag include and -LCS50? What does LCS50 do when I pass it to the compiler like Clang? Anyone have any idea? OK. Yeah?
It lets you access the CS50 library?
It lets you access the CS50 library in that it tells the compiler Clang that, hey, this is where you actually go to get these functions. It's not, so the include CS50.h says there are these functions somewhere. The LCS50 says go to this spot in your computer that's CS50, the CS50 library, and pull up the actual code for these functions. Anyone, does that make sense to everyone? So these are all things that you pass to or that are to help your compiler along with making the code actually run. Quick question, do people know what a compiler is? Good sense? It's basically taking the written code that you have, converting it to binary, converting it to machine code so your computer can actually understand it. All right, and without further ado, we're going to go into the more actual question, or like actual coding exercises that you guys will have some fun sinking your teeth into. And Lexi will go over that.
OK, awesome. So we're going to go over 2 questions here. So the first one is actually, you can see it's a little bit small right here, but essentially it's asking you to write a program to take some user input. I'm not sure why there's a black square there. It's mysterious. Should be fine though. So it wants you to take a user input in Celsius, convert that to Fahrenheit, and then tell the user what the temperature would be in Fahrenheit. So you can see a sample input-output sequence here. The user inputs, after Celsius, the bold refers to user input, so the user input's 100, and the program outputs Fahrenheit 212.0. And an important distinction in this program is that we're going to only have 1 decimal place. So we'll see how to do that as well. And so another thing to note is that we're using a.out because Clang, the compiler, automatically names its binary files a.out unless you specify it with a certain flag to give it its own name. But for now, we're just going to use the default a.out. So let's actually take a few minutes and try to write up some code for this yourselves. So in so it's 4:15. So at 4:20, we are going to come back and spaces. Thanks. Cool. This is sort of like what we call skeleton code, in that it's a skeleton, but you have to fill in kind of the meat of the program to actually make it run. So you can see the include directives up there to include CS50 and standard I/O. I noted in a comment the actual formula for converting Celsius to Fahrenheit, in case you don't remember from like high school science or whatnot. And then this is just a skeleton for the actual main function. So everything you write is going to go here. And in order to actually get to this space, so CS50 spaces can be accessed using this URL, which Dan is going to write on the board. And I'll dictate as well.
cs50.net/spaces /
lowercase q, capital W, capital L, lowercase c.
Capital
Sorry,
W.
Y.
Y?
Yeah, no. Sorry.
Okay. Okay.
QYL. Yep. Lowercase c, capital Y, capital W, lowercase f, lowercase g.
All right. Yeah.
So I should see everyone's names kind of popping up here. Awesome. This looks great. This means people are joining the space. So if you haven't had a chance to play around with spaces yet, this is actually what you're going to be using with your TS in the section all semester. How it works is kind of everybody writes their own code, and nobody can see it until you press the save button, which I'm pointing to right now. So I'm going to press save. And if you all go to my name, which is, you should be able to see it in people in this space, which is Lexus Barrel Ross. So how it's going to look is you click on my name, and you're going to see revision 5, which is the latest revision. Copy only revision 5 into your space by clicking on it. All right, so let's go through this problem together. And I'm actually going to write the code up here on the screen. I'm going to zoom in a little bit. And then once I'm done, you can copy my latest revision into your space if you want to see the kind of final solution. Now, Spaces has capability for me to go in and see any of the code that you guys have written, but just because it's such a large section, and we don't really have the same kind of like discussion capabilities as a smaller section, we're just going to go through and I'm just going to write the code. But definitely stop me with questions at any point, and we're going to go through it kind of step by step to make sure we understand each part of what's going on here. All right. Can everyone see this text here? Does anyone want it bigger? OK. So what's the first thing we're going to do here? Well, essentially, since we want to get input from the user, and we want it to be kind of a good experience for the user, we actually want to tell them what we're looking for. So let's print out exactly what we want from the user. So just, don't bother raise your hand. Just like rattle it off. What is the command to print something to the screen? Awesome. OK. So printf. Sure. So printf, as we've seen frequently in lecture, is the command to print something to the standard output stream. So we want to ask the user to input a temperature in Celsius. And now we actually want to take the input that they give us and store it into a variable. So we've learned a little bit about types. Can someone remember what type we would want for a variable with a decimal place in it? Float. Yeah. Awesome. It's a float. So and how are we going to, big hint, get the float from the user? Yeah. Cool. And the user could potentially be mean and try to give us like a negative number, but let's not worry about that for this problem now. You're going to worry about that a little bit more on your homework on the problem set. So let's assume they give us a good number, and now we actually have to convert that float from Celsius to Fahrenheit. So let's consult our formula up here, and let's create a new variable and call it Fahrenheit. I studied the spelling. It's kind of crazy, I know. And let's count on the order of operations to kind of do its job here. So we want to do, but we'll use parentheses just to be completely verbose and clear. So Celsius times 9 divided by 5. I'm going to zoom out just a little bit so this can fit on one line, but I'll zoom in again for those who can't see farther in the back. Sorry about that. Strange cursor issues. OK. Plus 32. OK. OK, does anyone have any questions about how I put in the formula or any issues with that? Yeah?
Do we need to put printf before the float Celsius, float Fahrenheit script lines? Does it matter which order they're in?
Does it? So the question was, do we need to printf before we actually ask for the float? The answer is that we do. That way, that the cursor that the user gets to input their float will occur after the printed C, right? So and it makes kind of sense if you think about it logically. Like you're asking the user a question, and then you're receiving an answer. So it prints C, and then there's a cursor, then the user can type in the value, as we'll see later on when we demo. Yes?
Why do we use a float, not a double?
So a double, essentially, as the name implies, gives us double the amount of precision as a float. But typically in C, in this course, for memory reasons, we're going to use floats. And this is really all the precision we need just for kind of basic temperature conversions. Typically, doubles are more used in the Java language. Floats are more common in C. All right, awesome.
One more.
Oh, one more. Yes.
Where do you put the space bar? Like, if you could click on the space bar before an actual times Celsius, does it matter?
Oh, no, so it doesn't matter. I actually should have put another space here. But what does matter is that you're consistent throughout your code. So if you decide to use one style of spacing, make sure to keep it throughout your whole code, or you may get style points deducted. So consistency is key.
I think you were talking about that space.
Oh, you're talking about that space? By the C?
Yeah.
Oh, so that's just for looks, right? So that way, when we run the code, if we didn't have this space here, if it looked like this, the user would start typing in the number, and it would be squashed up right against the colon after the C, and it would look a little bit better if there's a space. And you can see that a little bit better once we actually run this code when we get it finished. Awesome. Yeah, one more question.
You don't have to put a decimal point after one of the 9, 5, or 2.
So you don't because of the order of operations. So because Fahrenheit is already a float, and as is Celsius, you don't need to explicitly cast any of these other numbers as floats. Although in other circumstances, when you're dealing with ints, you may have to put point to explicitly cast it as a float. Yeah.
I was just wondering if capitalization matters in these commands like Getfloat. If you
Yeah, good question. So the question was, does capitalization matter in commands like Getfloat? The answer is yes, it does. So Getfloat is, as Dan was describing earlier, a library function from the CS50 library, and it was written as capital G, capital F. So if you don't write it with those capitals there, the compiler is not going to understand what function you're referring to. OK, yeah.
is the argument for main always void?
Oh yeah, that's another great question. So the code that you copied from MySpace mistakenly had some more arguments. So the question was, is the argument to the main function always void, which essentially means nothing? So the answer is no. You may notice that the code you copied from my earlier revision had some what may look like nothing that really makes sense right now, some char star, argv, argc. Don't worry about that for now. But you'll find out later on they do make a difference. But if you're not using that sort of added functionality, which you'll learn about later, void is completely fine. All right. And we have one more step, which is that we want to actually show the user what the converted temperature is. So again, we're going to use printf. And let's say f, just for consistency's sake. And now we're going to do something a little bit tricky. So we're going to use a flag or a special kind of notation to tell the compiler to, or to tell printf to only print one decimal place. And does anyone happen to know what that's going to look like before I type it out? Yeah. Yeah. So it's really close. 0.01f for one. 0.01% f. And then we have to remember to include the other argument to printf, which is the variable itself, which is Fahrenheit. One last step. Can someone remember what that is in our main function? Yeah, up there.
Return.
Exactly. So since this is main returns an int, we want to also return an int.
Except percent needs to be on the outside.
Oh. OK. Sorry, guys. That was a mistake. So the percent, it comes before 0.01. So it's percent 0.01f. Those are kind of hard to remember. Many people like me just look them up whenever we use them. Yeah, up there.
Why is it 0.01 and not 0.2 or 0.1?
I don't know, actually.
Yeah,
Do you know
the
that?
reason it's either 0.0 or the reason it's 0.01 as opposed to like 0.02 or 0.2 or 0.1 is fairly arbitrary to the way that the programmer originally designed it.
That's not what I meant. I'm not asking like the reason, like the programming reason why.
Oh, okay.
I have it written as 0.2 and it delivers to.
Yeah, so we were only wanting one.
Oh, okay. So
Yeah.
you could do 0.1 then.
0.1 would probably also work.
Oh.
0.01 works as well.
OK. Oh, the O might be to show 0 if it's like less than 1.
Oh yeah, I think that is right. Yeah. So the 0.01 would show a 0 if it doesn't have anything that would go there naturally. So if you were, say, putting in 100 for Celsius, it would come out to 212 normally in Fahrenheit, like 212 exactly. If you have the 0.01, it will show 212.0 as opposed to just 212.
That's right. So reading it basically says, tells printf, print a decimal point, print and print a 0 if necessary. If not, print the first decimal digit.
And we'll explore some of this when we're actually running the code.
Yeah.
So I put 0.1 and it still printed it.
It still prints the 0?
Yeah.
OK.
Cool. All right. More questions on this code before I compile and run. Does anyone see any bugs here, first of all? Anyone see something that should be here? If this were your problem set, what would be here that is not there right now? Yeah, great. So I didn't include comments because I'm delivering them orally. But if I were writing this in a problem set, I would definitely want to put comments to indicate what I'm doing, essentially, in the program. And you'll kind of get a feel for it as you move through the semester. the right amount of commenting. You don't want to be too verbose and put lines and lines of comments for each of your lines of code, but you also don't want to be not verbose enough and leave the reader to try to figure out what the heck your code is doing. OK, cool. Let's try running this code. OK, I'm going to zoom out a little bit. Cool. So you'll notice there's a play button here. Let's click play.
Scroll that up a little more.
OK. Oh, yeah. So you'll notice here, just as in the spec on the problem set, there's the ./a.out. A.out is the name of the binary executable, which is a long word for just a file consisting of binary code that your computer is actually running. So as we expected, we have C here. So call it a number. 23. Oh. Where's my cursor?
Your program took too long to run. Just run it again.
My bad. OK. Spaces is picky sometimes. It wants you to think on your feet. OK, 23. Awesome. Does everyone believe this? Cool, because it works. OK. Let's try a couple more. Let's try an edge case here. In computer science, when we talk about edge cases, we mean kind of cases for your program to run that are sort of like on the very edges of like reasonable inputs, or that test certain corners of the logic in your program. And this makes more sense when we kind of do more complicated programs. Let's try 0. Awesome. We all know this. Cool. Any more questions on this before we move on to the next program? All right, awesome. So now we're going to, do you want to just use my computer?
Yeah, that's
OK.
easy enough. All right, so we're going to go and talk about making percentages. So we're essentially, in this next little exercise, going to take 2 integer inputs from the user, hoping for a non-negative numerator and a positive denominator, and basically dividing them and outputting what comes out as a percentage. So we want it to only accept non-negative numerators and accept only positive denominators, and keep asking for new ones if it hasn't gotten what it wants. All right? So yeah, give that a go. And
Oh, yeah, do you want to do the, oh, maybe people should copy my code.
Yeah.
No spaces.
Spaces.
I have a question.
Yeah.
If I'm using spaces
save
and I want to save that I just made the Fahrenheit conversion,
Yeah.
do I save it and then make a new?
We could just do a new space, or you may just want to copy and paste it to a text file or something, so you have it.
And I'll just change my name.
Yeah. So I just saved the latest revision of toFahrenheit.c. So if you go into quadruple A Lexus Barrel Ross, you can go in and copy that latest code and then start on this new one, which I think Dana's going to provide some skeleton code for as well.
Okay. Yeah. The latest revision I have on mine, so it's at the very top this time, is revision 4, and it'll have what you need to get started.
All right, and I'll copy that into mine as well.
All right. I think we're going to just start going over this, if anyone is interested. So
We're all interested.
we are going to start out just by declaring some variables. So we have a numerator. And for the sake of now, I'm going to call it, just start it with the value -1. And then I'll set up a do while loop. So when do I want it to loop? Like, when do I want it to keep asking? Yeah.
It's less than or equal to 0.
Why can't it be equal to 0?
Oh, no, that's for the
Yeah. So it's for the numerator, it's just while numerator is less than 0. Is less than 0. Does that make sense to people? We keep looping while the numerator is less than 0. We keep asking for new input and keep demanding that people or that they input new things. So I'll just have a little printf in here. What was it? Non-negative. Wow. And then we do the same thing as before, except we do a get int, just because we wanted to do it as percentages of ints. So equals get int. Okay, now a few things. Do I need this -1 here? No. Why not?
Because you're getting the numerator value from the user.
Exactly. But do I want to have the int declaration, or like the declaration out here? Yes. Why?
You have to define it outside of the loop, otherwise you're not going to have a variable for the rest of the program.
Exactly. Scope. Sweet. Does that make sense to everyone?
Wait, can you say that one more time? Sorry.
Okay, so if I were to declare this numerator inside the loop, if I had this instead of numerator being int numerator and I got rid of this entirely, numerator would disappear. It wouldn't exist outside of this loop. It would, because everything is within the scope of these curly braces. Make sense? Okay. So for denominator, we do something fairly similar. Int denominator equals, and I don't need the equals, do and for the while in this case, what do I want? What condition do I want it to still loop on? Less than or equal to 0. Denominator less than or equal to 0. Okay. And don't forget your semicolons, kids. Yeah, so we do the same thing as before. Printf a positive and we get a int from here. There we go. Okay. And then in the end, we want to print out some percentage. So to do this, what should our string look like? Printf. Any other ideas of what I can do here? Yeah.
Maybe percent point to that percent.
Yep.
Quotes, comma, and the expression.
Okay. I'll start with the first bit. Percent point to percent quotes comma or okay. And I'm going to throw a new line in here just because I like new lines when I'm doing things. But what sort of mathematical expression should I have here?
Parentheses, float.
Good. Why do I want to have it in float?
Say you can convert the integer to float.
Good, good. Float. Numerator. Okay. So I do float numerator divided by.
Denominator.
Do I do just denominator or do I do float denominator?
Just denominator.
Okay.
And you can multiply that by 100.
And I multiply that by 100.
I mean, like the entire expression.
Yep. Okay. Look good? Let's try it. negative 50. Good, 50. 0, and 100, 50%. It worked out just like we wanted. Does this code make sense to people? I'm going to save it so you can get a copy of it. But yeah.
Why don't you need to put before denominator?
Where?
Like when you see denominator equals it.
When I have it here?
Yeah.
Why would I have int before it?
Oh, because the other one had float before on the other.
Well, so that wasn't in a loop,
Oh.
right? So I declare this int denominator above the loop, and I don't have it in the loop because I would be declaring it a bunch of times and it wouldn't actually carry over to anywhere else in the program.
I think, yeah, the important thing to remember is that variables only need to be declared once. So imagine it's like introducing a new variable into the world, like calling it int or float or whatnot. And once it's declared, all you need to do to change it is just call it by its name, denominator, or x or y. You only need to actually call it an int just once.
Yeah.
Can you explain the difference between %d and %f, and if you ever declare a variable as a decimal?
So %d and %f in here?
Yeah.
So d actually refers to just a digit, not decimal, which is kind of confusing. There's no actual data type called decimal. And when you want to print out an int, you refer to it as %d or % whatever d. F is for float, which is, you think it'd be I, but it's actually d for int.
Yep. Yep.
So in the other program, why didn't we just do the same thing like when we were saying Fahrenheit? Why didn't we put like?
Oh, in the bottom here?
Yeah.
You could have.
Oh.
It would have been completely legitimate. I like doing it this way. Other people like separating it out into different lines of code. Either way works fine. Mm-hmm. What's up?
Explain what the %.
Okay, so the %, oh right, I was going to go over this. The first % is called an escape character, and it just says the thing behind this is not actually part of, or is not actually code. So this first %, right, the %.02f, all of those .02f means something to the compiler, or to printf as a function. %, I just wanted it to actually just print a % sign. So I'm not saying there's anything important behind it. I'm just saying there's a % sign behind it. Please print out a % sign. So %, then another %. Yeah?
Could you show what it would look like if you had a float bit on another line?
Yeah, sure. So I'm being asked to show what it would look like if I had this float numerator, all this math on another line. So float % equals boop. And I would get rid of this and just put in %. And it's doing the exact same thing. I just have another variable. Scroll down to what?
So that I can see the
What can't you see?
Sorry, I was going to space.
Yeah.
So if we were like replacing the escape character, like suppose you wanted to have like a $sign instead, just for example, like a $sign behind.
A dollar sign would be.
Dollar?
Nope.
Dollar?
It's just a dollar. Just $1 sign. Because a dollar sign doesn't mean anything to printf. The question was, do I need to have an escape character for symbols like dollar signs?
So sort of related. Are there any other cases that we should know of when the something like the % sign might mean something, so we have to put?
Yes. Not necessarily for the % sign, but the backslash. See how we have \n here? Like, let's say we actually wanted to print a backslash. We have to escape that, and this is going to sound confusing, with another backslash. So if we wanted to print \\, we would just have to type that, or for each additional backslash, another escape. Okay. And yeah. And another one, if we want to print out a quote. So basically anything that kind of like denotes something special within a string, we want to escape. So let's say we actually want to have a quote here. We would want to do \quote.
So it's usually a backslash.
It's usually a backslash.
Yeah, for some reason in here it's a percent sign.
Yeah. Mhm. Oh, this guy? This is just to say the thing that's being divided here is going to be treated as a float for the sake of the division. So in the case of, say, so in the case of 50 divided by 100, if I didn't have the float there, it would just be 0. That's all that would come out. Because 50 divided by 100, if you aren't including any decimals, is 0 point, and everything after the decimal is just truncated off.
Why don't we put it before denominator as well?
So the reason we don't put it in front of denominator is because when you're dividing something by an integer, it works just fine, right? Having a larger number on the bottom doesn't change anything. You can divide by integers just fine. It just doesn't really matter. You could. It wouldn't change anything. Mm-hmm.
So if you wanted 3 decimal places, would you put %.03?
Yep.
Yep.
You would put percent 0.03 if you wanted 3 decimal places. Mm-hmm.
And like the do command, what's the difference between that and just doing while at the top?
Okay, so a do while versus a while loop are two fairly similar commands. The only difference is you run the code once. You run the code inside the loop one more time, or like one time before making any actual check, right? So it's also the reason I can say denominator without giving it a number, right? So if I said int denominator and then while denominator is less than or equal to 0, it might never even run the code inside. It'll make that check before. So here, if I had a while loop here, so yeah, if I had this while loop here, I would have to have denominator equals, say, -2, or some number less than or equal to 0. So it would actually try running the code inside first. So generally speaking, you want to use a do while loop instead of a while loop when you're asking for user input, because running the code once, asking for something the user will give you, is generally your best solution, as opposed to just trusting whatever you put in to start with.
And do is always followed by while.
Do is followed by some chunk of code that you want to execute, and then while some condition is.
Think of it like one command, sort of like broken up into 2 parts. It's a do while, not like, oh, here's a do, and then I'm going to add a while. It's just a do while.
I understand the reason why we're using the 2% signs, but can you explain again why we have to have the 41% sign at the start?
Okay, so the 1% sign is just saying print, like printf, here is a command that I want you to fill with some number, right? So I want you to fill it with 2 decimal places and a float. And you'll find the float at the end of the command. It's this percent. Does that make sense?
Yep.
Okay.
Is there something about the do while loop that if the condition is not fulfilled, and like if you get like a negative number to your numerator, it'll just keep asking and like will keep asking the user, or?
Yeah, so if do while, like if the condition of while is not fulfilled at the end of the do while, it'll run back to the start. It's just a loop. So it's like a while loop that the condition hasn't been fulfilled on. It just runs one more time. Yeah.
So if you were doing this, and can you, for your while, put 2 conditions there?
You can. It depends what you're asking. So you can put 2 conditions in a while loop if you have it all within some sort of Boolean operator, which it sounds ugly, but it's basically this denominator is less than or equal to true or to 0, either returns true or false, right? It's either less than or equal to 0 or not. So you can do other Boolean operators that'll say, while this is also true or while this is also false. So it's things like and numerator is greater than 0, right? That's asking, this will only loop while denominator is less than 0 and you have a positive numerator. Two ands.
Yeah, we'll cover that more later.
Yeah.
What if someone doesn't put in a positive numerator or denominator? I'm sorry, if they put in a negative numerator, can you prompt them to say put in a non-negative numerator and have like a command for that? Because right now it just says
You could.
non-negative numerator. What would we use for that?
So you'd have an if condition.
Okay.
So like if numerator is less than 0.
You probably just want to break it up into more steps, right?
Yeah.
So the first time they put in the input, we just say, give us a numerator or whatnot. And then if they do the wrong thing, this might be the case for a while loop rather than a do while, because we have the first time we have the get in, and then while that input is bad, we keep asking them for further input with a different sort of text, like that that didn't work, or give us a non-negative numerator instead, that kind of thing.
Yeah. Yeah.
How do you clear the stuff that is the terminal?
Clear.
You can't
Oh,
type
so
into it.
that's actually, this is not a real terminal. The question was, how do you clear that stuff down there? The answer is it's not a real terminal, but let's say you are in a real terminal. Clear. That's the trick. Oh, it's a cat. Where did the window go?
Did you lose it?
Yeah.
Just another one. It's that one, right?
No, that's all my stuff.
No.
Yeah.
Yeah.
There.
Yeah.
Does clear work if you have, like say you run a program by mistake and it's like asking you for something and you don't want to? How do you
Control C?
Yeah, so if you're running a program and something is not going the way you want it to and you just want to exit the whole program, Control C. Even if you're on a Mac, not Apple C, Control C. Important.
Yep.
Did you have the correct version on the revision in your profile?
I think it's saved, isn't it? Yeah.
Yeah. This is the space. Yeah. Yeah. I think it's revision 11.
Yeah.
Does C make any assumptions about like what a variable is if you define the variable but don't assign anything to it right immediately?
Well, so it'll only accept ints into that spot. So if you declare it.
If I just did int denominator semicolon, does it assume that it's equal to 0 or anything?
Nope.
Or
So if you don't assign, say, int denominator to any value, it could be anything. It's the old memory that was in that location. So it could be negative 2 billion, it could be positive 2 billion, and it could be anywhere in between. So if you're actually running things, make sure that you declare assign a value to the variables. This, it doesn't matter because we're immediately assigning the value, but generally speaking, yeah. All right, any other questions?
We can also just take general questions at this point.
Yeah.
On lecture material, PSET material, anything you've been wondering about, this is a good time to ask those.
Yeah.
So in the walkthrough, Smiler mentioned the round function. Would you mind elaborating on how to implement that?
Sure, how to implement that?
She said you use a round.
Oh yeah, so just so we all have the same sort of vocab and stuff, implement generally means actually writing from scratch. So I don't think she was talking about sort of writing the round function, she probably just meant how to use it. Implement means sort of create. So we generally a time when we want to use the round function is I mean, as sort of the name suggests, if you want to round, can you give me a little bit more context as to like what the problem was?
To avoid the imprecisions of decimals, for example, like the float.
Yeah, so the issue with floats that we've kind of alluded to is that because of the way they're stored in the machine, they're not 100% precise in the way that like you might think your calculator would store them. So it might make sense at some points. It's hard for me to like sort of describe, like show an example without knowing what the context was from. I don't know. Can you think of something? Dan?
So if you're asking for, say, numbers greater than 10 and you're using floats and you're adding 1 to a float every time, it will sometimes wait until you've gotten to 12 before it'll say this is actually a number greater than 10. Floats have some serious issues just between like the 32nd and 33rd decimal place that'll go, so it might be 9.99999999999, or it might be 10.0001, right? It doesn't really distinguish between the two, so if you're waiting for things greater than or equal to 10, you might not get there at the 10th, what you think is the 10th iteration. You might get there in the 11th.
Yeah, it's essentially, yeah, it deals with when you're sort of looping over a lot of floats, that's when the imprecisions happen.
Yeah.
I think, are you talking about how, because I don't know, so basically it's like on the P side it's telling you it wants you to round the float value, and if you put in like 4.24 for the amount of the amount of change you need back, and if you just do like times 100, it'll actually change it to 423. So
sometimes,
I think it's just
yeah.
like how do you use the round function in the actual code
So
to make it so it doesn't do that?
if you're rounding like 424 by multiplying it by 100 and making it into an integer, it will sometimes make it 423 because of that imprecision. And so things you can do is just add 0.000003.
I think they actually they
That-
to use the round function.
The round function, there's probably a math function, something in the math library.
Include like the math.
Include
Yeah,
math.h,
yeah.
and there's probably a round function.
And just like round parentheses.
Essentially, because you want to round to the nearest
Let's
cent,
pull up the man
right?
page.
Yeah.
So a handy tool, if you don't know, here, you pull up the terminal, is if you go to math.
Cool. So you can see, so man is short for manual, not man. And it allows you to look up more information about any given function or library that you might be dealing with. So I just typed in man math. Oh, let me zoom in.
We could try man round too.
Sure.
And this will list out, like man math will list everything that's in the man library, or the math library.
Oh, that works
which
too.
will include, and so yeah, we also have round.
Yeah. So I just did man space round. You can see here in the synopsis, it says hash include math.h. So that's kind of like cs50.h, standard.io.h. And it looks like it's actually overloaded, meaning it like takes different types of arguments. So you can round doubles or floats so right.
Round versus round f.
Round f. Did Zamilo mention round f? Which is round?
In the walkthrough, it was just round and then like the parentheses.
Okay, so it probably was using the double then, as opposed to a float.
Yeah.
Okay, so yeah, you would multiply it by 100 and then round it, and you'd get the number closest to it, I think. Wouldn't you?
So the round function returns the integral value nearest to x, rounding halfway cases away from 0, regardless of the current rounding direction. So essentially, you would want to only round once you're at like an integer value. So you multiply by 100 and then round. Does that make more sense?
To use that function in a C file, do you need to put round float? Like if your variable is called q, do you have to put round parentheses float q and then in parentheses, or can you just put round and then q in parentheses?
So if you were rounding, trying to use this function actually, you would take that round, or that q, is q a float, or is, like how is it declared?
Q is a float.
So if q is declared as a float, you would just take round and then give it q. You might have to declare it as a double in this case.
Yeah, unless you want to use round f.
You,
Round f
Yeah.
Q in quotes?
No, not in quotes, just Q.
No, sorry, not in quotes, in the parentheses.
In the parentheses, yeah.
All right, yeah, sorry that was a little bit confusing. Any more questions?
Yeah.
So rounds only rounds to integers?
Yes.
Yeah, round only rounds to integers.
So if you wanted to have something exact, that means you would have to multiply by 100 and then divide by 100 again if you wanted to get it back.
So if you wanted to get it into like a decimal form?
Like the example, for example, when you had like 1.25 and then when the answer became 1.24, if you wanted to keep that as 1.25, you would multiply that by 100, round it, and then divide it by 100 again to get keep 1.25.
Yeah, so the question is, would you, in order, since rounding, as the man page says, rounds to the nearest integral value, does that mean that one would want to multiply by 100, do the rounding, and then divide again by 100 to, say, get the correct dollars and cents value? And the answer is, wait, no?
Well,
Maybe
so,
we should do that.
no, I mean, if
Yeah.
you're just getting a float value, if you start with the float value of 1.25, that's how it's going to be interpreted. So if you multiply it by 100 and then divide it by 100, it's still going to be interpreted as 1.25 or possibly 1.24999999999.
I think the question was like, you would multiply, then use round, then divide. So it's like.
Yeah, I still don't think it changes anything, though. I
Okay,
think it's
because
still
like round does, it uses integers. So if you try to round 1.25, you just get 1. So I think in order to get like the additional precision, I think if that's what you're talking about.
So in what instances do you use round then?
So in this case, if you want, say, the number of cents from $1.25, right, you would multiply by 100, round, get 125, and leave it as that, as cents, as opposed to trying to convert it back into dollars and cents.
Oh, yeah, for sure.
Yeah.
Why do you need to round that?
So if you multiply it by 100 and then immediately convert it to an integer, which is the more useful form, that's when you deal with that imprecision, right? So it might be 124.9999999, and so if you then convert that to an integer, it just drops everything off that's below the decimal. Exactly, instead of 125, which is why you want to round. Mm-hmm.
Sorry, could you repeat what you said you should do as opposed to what you shouldn't do?
Okay, so what you should do is, if you start with 1.25, multiply it by 100, and then round that whole number, that 125 or 124.999, and get that to the nearest integer.
So if you round that, puts it to the nearest integer.
Mm-hmm. Yeah.
Is there a way to limit how, if you ask for a float to be inputted, is there a way to limit how many decimal places you can input a float to?
Not using CS50's implementation, I mean, you can count kind of like how large the input is given by the user, but that would require kind of a new implementation of Getfloat, and so you don't need to worry about that.
Yeah, so if they say input 1.256, you can just use 1.25, or you could do 1.26. Either way, I think the implementation says you can
just have it round to
whatever it wants.
Yep.
Yeah. As long as you do some sort of rounding. All right, anything else? Doesn't have to be about rounding?
Yeah.
If we want to check to see if the style that our code's written in is like appropriate or the best style that it can be, is that the sort of thing we bring up in section or at office hours, or is that the sort of thing we can post privately on the thing and on the discussion and then ask for advice on, or?
So like we don't at office hours or on CS50 Discuss, we won't actually like grade your piece in advance for style, but I think like probably the most helpful thing you could do would be to look at examples, and you should be able to find that in section code, which will be which should be distributed online, as well as the lecture slides. There should be examples of code, and then but if you have sort of individual questions about a certain style issue, definitely feel free to ask that on CSFD Discuss in office hours or on your own time. But if it's more general, just like look at my code, it's best to kind of use examples and try to fit your code to that. And I believe there is a style guide.
Yeah, no, there's the style guide.
Yeah,
the style guide's
guide.
awesome.
Yeah.
It teaches you everything you need. And it covers pretty much every example known to man. Or at least known to me. Anything else? All right, cool guys.
Have a
Thanks for
great
coming.
night.